During this session, I'm going to talk about some of the basics of static electricity. Hopefully by the end of this session, you'll have the tools that will allow you to hopefully explain why, when someone places their hands on a Van de Graaff generator, causing them to become more charged, their hand goes like, their hair can end up going like this if we have the right environment. So let's start off with the basics. Okay. If we're thinking about charged particles, we can have two types. We can have positively charged particles and negatively charged particles. We can also have things which are neutral, which are either negatively or positively charged, but they wouldn't be an interaction of interest to us at the moment. So a positively charged particle and a negatively charged particle will attract each other, whilst a positive and a positive will repel, and a negative will also repel. So what we find here, we've got to remember, is that opposites attract and similar charged particles repel from each other. More often than not, we'll be talking about the negatively charged particles being electrons and the positively charged particles being the nucleus of an atom. More often than not, but that's kind of a starting point that you can is useful to think about. So let's think about first of all a conductor. Now a conductor is a special material which allows electrons to flow freely around from molecule to molecule. A metal sphere, for instance. So that means that as they can flow around, when an object, a conductor, gets charged, so in this case some electrons flow onto the metal sphere, they will immediately disperse and distribute around the surface. They want to be as far apart from each other as possible because they're repelling. So conductors allow the flow of electrons, whilst in reverse, an insulator doesn't allow the flow of electrons. And what happens if charge or electrons are transferred to an insulator? They stay put and motionless at that point of contact and don't move anywhere else. So that would be an insulator. So with that thinking, what is a conductor and what is an insulator? Pause for a moment. Think. Clearly, sphere A must be an insulator because the electrons are unable to distribute themselves evenly around the sphere, while sphere B shows the electrons trying to be as far apart from each other as possible, and that means they're able to move around, and that means that sphere B is a conductor. So how do we charge things? We've spoken about conductors and insulators and the idea of the original particles. How can we actually charge something? Well, there's three ways to do that: through friction, through electrostatic induction, and through contact. Friction works fairly simply. If we have the right materials, what I can do is, if I have a cloth and a plastic strip, and by rubbing vigorously, I can remove some of the electrons from the cloth and I can rub them off onto the plastic strip. So now I have a positively charged cloth and a negatively charged plastic strip. In fact, on a Van de Graaff generator, there's a belt which goes up into the metal sphere, and that's constantly rubbing, and it's actually a similar impact there. And what they're doing is that there's a transfer of electrons which causes a Van de Graaff generator to build up charge through the same frictional process. So that's one way. You might notice that if you bring a negatively charged rod into a piece of paper, the piece of paper will stick to the end of the rod. Yet you should recognize the paper has no charge, it's just a piece of paper. It would normally be neutral. So what you're happening here is you're inducing a temporary charge. So by introducing, for instance in this case, a negatively charged rod, that drives away the electrons which can move, so causing one side of the paper to be positively charged and therefore attracted, and the other side of the paper to be negatively charged, and that small area of positive and negative are then attracted to each other, which is why a piece of paper will get stuck onto a charged rod. The same thing would go vice versa if it was a positively charged rod as well. So that's inducing a temporary charge. Finally, and this I'm going to use the example of charging an electroscope, is by contact. Now, if I have a material which is charged, those particles, in this case these negative electrons, want to be as far away from each other as possible. So therefore, if they're placed in contact with a conductor, these electrons will happily flow away to try and distribute that charge some more. So that means that contact will allow for the distribution of charge and cause an object which was previously neutral to then be charged. So that's an overview of static electricity. Thinking back to the Van de Graaff generator with the crazy hair, what you're doing is by charging a person up, they're becoming negatively charged, for instance. Now, all the hairs will be negatively charged as well, and they want to be as far away from other negatively charged hairs as possible, which causes the crazy hair which we saw in the opening slide. I hope that this helps.